Hello everyone, myself Murli Krishna from BIT CSE department. Today I'm going to explain about knapsack using branch and bound. So what is knapsack? You are given X items and you are given their weight and their value, and you are given a bag which can carry the items up to a certain weight. Now we have to put the items into the bag, a certain number of items into the bag, such that we get the maximum profit. This is the knapsack. Now, the knapsack problem can be solved using multiple methods like brute force, zero one knapsack, greedy approach, and branch and bound. So, today I'll be explaining about branch and bound. Here is an example. First, we have four items with their weight. The weight of item 1 is 4, weight of item 2 is 7, weight of item 3 is 5, and weight of item 4 is 3. And we are given their values. Weight of item 1 is 40 to 42, weight of item 3 is 25, and weight of item 4 is 12. The first thing we have to do is calculate value divided by the weight for each item. So first, for the first item, 40 divided by 4 is 10. Then for the second item, 42 divided by 7 is 6. Then for the third item, 25 divided by 5 is 5. And for the fourth item, 12 divided by 3 is 4. So, and the knapsack capacity is 10. Now that is the weight of the bag is the knapsack capacity, that is equal to 10. So this is the important formula for calculating the optimal solution. Upper bound is equal to V, that is this value, plus W, which is the knapsack capacity, minus the small w, which is the weight of each item, into Vi plus 1 by Wi plus 1, V by W, that is the value by weight given here. So let's calculate it. First, we don't consider any item. So weight is 0 and value is 0 initially. We calculate the upper bound using the formula. So upper bound first, value is 0 plus 10 minus 0, 10 into Vi plus 1 by Wi plus 1, I plus 1, which means we have to consider the next item. So we have to consider first for item 1, which is 10 into 10. So it is 100. Upper bound is equal to 100. So then now we have to split it into two cases, with 1 and without 1. So first let's calculate for with 1. So weight of item 1 is 4 and the value is 40, which we have written here, weight is 4 and value is 40. We calculate the upper bound. Upper bound is equal to 4 plus 10 minus 40 plus 10 minus 4 is 6 into Vi plus 1, Wi plus 1. We have to consider for item 2, I plus 1, so we have to consider for item 2. 6. So 6 into 6, 36, 36 plus 40 is 76. Now without item 1, the upper bound is, so the weight is 0, V is 0, since we have considered no item from the first. And now we calculate upper bound is equal to V, which is 0 plus W minus W, 10 minus 0, 10 into Vi plus 1, Wi plus 1. For item 2 it is 6, so 60. So the upper bound here is 76, here it is 60. So since this is less, since without 1 it is lesser than for with 1, this is inferior and we ignore the without 1 condition. So now split for the with 1 into two cases, with 2 and without 2. So with 2, the weight of item 2 is 7 and the weight in the knapsack is now 4. So 7 plus 4 is equal to 11. Since it exceeds the knapsack capacity, which is 10, this solution is not feasible. We ignore this case. So now without 2. Without 2, the value remains the same. Weight is 4 and value is 40, since we have not added any other item. Upper bound is equal to value 40 plus W minus W, 10 minus 4, 6 into Vi plus 1, Wi plus 1. Here I is 2, so we consider I plus 1, 3. Value by weight for item 3 is 5. 6 into 5, 30, 30 plus 40, 70. So now for the without 2 condition, we now split it into with 3 and without item 3. With 3, the weight becomes, so since the weight of item 3 is 5 and the weight in the knapsack bag is 4. So 5 plus 4 is equal to 9, and the value here is 40, and value for item 3 is 25. 40 plus 25 is 65. Let's calculate the upper bound for this. Upper bound is equal to V, which is 65, plus 10 W minus W, 10 minus 9 is 1, into Vi plus 1 by Wi plus 1. Here I is 3, so I plus 1 is 4, so we take 4. 65 plus 1 into 4 is 69. 69. So now without 3, the weight and value remain the same, which is 4 and 40. And let's calculate. Upper bound is equal to 40 plus 10 minus 4 is equal to 6, into the value by weight is 4. 6 into 4, 24. 40 plus 24 becomes 64. Comparing these two, we have 69 here, 64 here. Since this is inferior, we'll ignore this case, and for with 3, we'll split it into with 4 and without 4. So with 4, the weight of item 4 is 3. So 9 plus 3 becomes 12. 12 exceeds the knapsack capacity, which is 10. So this condition is not feasible, we'll ignore it. Then without 4, the weight and value remain the same. Upper bound is 65. This is the optimal solution. And now we can also calculate the profit we get from it. So before that, let's calculate the upper bound for without 4. So how it came 65? Upper bound is equal to value, which remains the same, 65, plus W 10 minus 9 into Vi plus 1, Wi plus 1. In this case, we'll consider it to be 0, because now we are in the 4th item, and after 4th item there is nothing else, so we'll take it as 0. So it becomes 65. So upper bound is 65. This is the optimal solution. So now we have to find the path how we came here. So first we considered without 1, then we ignored 2, we considered 3, and we ignored 4. So 1 and 3 we should put in the knapsack bag to get the optimal solution. The profit we get from this is, we have to add their values, which is 40 plus 25, 65. 65 is already given here. So it is 65. Now we can compare, we can verify the solution by using brute force as well. So by considering 1 and 3, we have already gotten 65. Then if we take 1 and 4, we'll get 40 plus 12 is 52. 1 and 2 can't be taken. 7 plus 4 is equal to 11. It exceeds the knapsack capacity. And again, 2 and 3 cannot be taken. It exceeds the knapsack capacity. 7 plus 5 is 12, which is greater than 10. So we'll ignore that. 2 plus 4, 7 plus 3 is equal to 10. So 2 and 4, what weight we get? 42 plus 12 is 54. Then after that, we can take 3 and 4 case. 5 plus 3, 8. Yes, it is less than 10. So we'll take that case. 25 plus 12 is 37. So we see 1 and 3, by taking 1 and 3, we get the most profit compared to all other cases. So 1 and 3 is the optimal solution, and the profit we get from it is 65. Thank you.